For our next example, we are going to write 0.87 as a fraction. So just like before, our step number one, we're going to use the variable x. We can use any variable we want. We're just going to keep on using x. So we're going to let x be the repeating decimal. In this case, 0.87 bar notation. Now this time, this number has two repeating numbers, two repeating digits. So we are going to multiply everything by 100 because there's two repeating decimals. So multiply both sides of the equation. Let me fix this. Both sides of the equation by 100. So I'm going to write my equation. 100 times x is equals to 100 times 0.7. And like I said before, we multiply by 100 on both sides to keep it equal. Whatever I do to the left side of the equation, I must do it to the right side of the equation to keep it balanced. All right, so I'm going to multiply that. 100 times x is 100x. 100 times 0.87. Remember, we are just moving the decimal point over twice to the right, two zeros, two places, tenths, hundredths. And then remember, 87, 87, 87 repeats forever and ever. So when I move the decimal point over to the right twice, my new number is going to be 87. But then I'm going to bring one set of repeating decimals, 87. 87. Now, step number 3, I am going to subtract the value of x. Subtract the value that we gave x, the value of x on both sides of the equation. So I'm going to write my equation again. 100x is equals to 87.87 bar notation, and then I'm going to take away the value of x. In this case, it's just x. I'm going to write x, and then I'm going to take away the repeating part, which is 0.87. And just like I said before, imagine that I have 100 x's and I'm going to take one away. Imagine that I have 100 x's. This means 10 times 100 times x means 100 x's. And if I take one x away, I'm going to end up with 99 x's equals 2. Now this, imagine that 87, 87, 87, 87 repeats all the way to infinity. But then I'm going to take the repeating part, all the 87s that repeat, I'm going to take them apart. I'm going to take them away because I'm subtracting, right? So what I have left is just the whole number, or the two, 87 as a whole number. And now my new equation is 99x is equals to 87. Step number 4, I don't want 99x's, I don't want 99x. So this is a multiplication, 99 times x. So the opposite of multiplication is division. So I am going to divide both sides of the equation by 99. So I'm going to rewrite my equation. 99x is equals to 87, and I'm going to divide both sides of the equation by 99. So I'm going to divide by using a division line, just like fractions. So now 99 divided by 99 and 87 divided by 99. The reason I have it on both sides is because whatever you do to the left, you must do it to the right of the equation to keep it balanced. So now 99 over 99 becomes a whole, so it's 1x, but I'm not going to write the 1, I'm just going to write x. 87 over 99, that's okay, yeah, that's an okay answer. It's a fraction already, but I think we can simplify this. I'm going to divide by 3, the multiples of 3. And when I divide 87 by 3, it's going to be 29 over 33. And that's my answer. I cannot simplify this further. 29 is a prime number. So here we go. I'm going to show you. I'm going to divide 29 divided by 33. And there it is. You see 87, 87, 87, 87, 87. And then because the calculator automatically rounds up, the last number is 9. But just to show that this number keeps on going forever and ever, the calculator is rounding up. Okay, so that's it.